Hello student, this video is covering the tutorial 5, question 4, 5 and 6 for Newton-Raphson load flow. So for the question 4, as you can see here, it's a two-bus test system, a very simple one, and voltage of bus 1 is given as a 1 with angle of 0, and bus 1 is connected to generator, so it's a slack bus. The voltage and the angle always constant, but bus 2 is connected to a load which is 150 megawatt and 50 megawatt, and the S base, yeah, here is the base of the system is 100 megavolt amp. So you must divide. It is strongly suggest to divide these two value at the beginning to 100, then 100, and find out the value here, which is 1.5 and 5. Sorry, 0.5 here, 1.5. And don't forget, here they are uh, absorbing the power, not generating the power. This is generator, this is load, totally different. Okay, and then the Y, which is the inverse of impedance between bus 1 and 2, is given here as a 2.8 minus j 9.6, and in the this is the Cartesian form, and in the form of the phasor is 10 with the angle of minus 73.74. Then the P and Q for bus 2 is given in the form of equations. It's a very gentle one given to you, and then ask you to calculate the voltage of bus 2 and the angle of bus 2 after two iterations. So step 1 in the solution of this one is to construct the Jacobian matrix. Since the Jacobian matrix change in each iteration, the values, the calculation is done for one time. The calculation I talked about that is this one. It's done for one time only, and then means for the first round is 10 v2 v1 sine blah blah blah, and the others also in the same, but the v2 is will change in the iteration. So let's do it for a simple one. Round p2 over delta 2. Okay. Here we don't have any delta, so this one is simply 0. Okay. And then here we have 10 v2 v1, which this one is a constant value, so we have this value must going the other way. So we should find out the cos inverse, which is minus sine, and then the others should be in the form 106.26 minus delta 2 plus delta 1. Then here also we have another one which you have to find out the uh, round of delta on that one. So since it's delta 2, become times minus 1. So minus 1 times minus, it's positive. So you can see here 10 v2 v1 sine, and this is j11. In the case of next one, which is round p2 over v2, based on new values and new techniques I learned you, we should find it as a round of v1. So here we have v1 again, here is 0 since there is no v1, so easily you can ignore this one, and then the final value is 10 v1 v2. Sorry, I think we should set divide by v2, yeah, not v1, since v1 is constant. Okay, so v2, so by v2 you can see, okay, ignoring this one which is v2, and for this part, okay, we have the derivation of that one become 2 v2. Again we have to times this final value by it v2, So again, this one back and become this one become V2. So if you look at this one is 10 V1, I added V2 by myself cos. The angle is constant, 20 V2 power of 2, and this is J12. Then Q2 over delta 2. Here is Q2 delta 2. So again, here is 0. Okay. Delta 2 is here. Inverse of this one is a cos. So a minus, it become inverse of this one is a cos. And oh, here we have a minus. I searching why is positive. So this one is a minus times minus become positive. So here is a positive 10 V2 V1 and others. And the final one is the Q2 over V2. You can see by here. Again, V2 must ignore here. This one is 2 times V2 after derivation uh, delta V2. Okay, then when you calculate that one, you have to times it by another V2. So again, this one back become V2 again, and this one power of 2 coming back to here. So you can see minus 10. So since minus, we haven't touched it, everything at the same point. So sometimes you ask yourself why we should times it by V2 here and here. If you check it correctly, if you look at these equations in a good way, if it's bigger network, you will find out, okay, by this V2, as you review the books also, Stevenson book, you can see no need to calculate few of what we call it variable here means sometimes two of them become exactly the same. So you can use that too in the same case without any calculation. So make it easier for you. Otherwise, of course, no need to times it by absolute of V2 and you can calculate everything. Nothing changed as I mentioned in the class. We just times it by V2 again divided by V2 or VI, whatever it is. Okay, load expression, as you can see, as I mentioned, divided by 100, and the minus here is exactly the meaning of the load, means absorbing the power. And then mismatch, this is the mismatch formula. The mismatch, it means how much we expect to absorb or generate, and then how much exactly we have based on the value of equations. So P2 is coming from here. P2 is here. So in the first round, we know that the voltage for bus 1 is 1 with the angle of 0, correct? So you can replace it as a 1 and angle is 0. Then for the V2 it is assumed that the voltage, this is for the first iteration. Okay, this is for the 0 iteration, sorry. So again, the value is 1 and the angle is 0. So from this equation, you are going and checking whether the P2 schedule minus P2 calculated based on that one are exactly the same or not. If the value here is less than a settled number, in the real one must be 0, but reaching to the 0 is very tough and very timey. So because of that, we usually consider it as a bigger value, 0.03, which is given in the assignment, or another value 0. Means 10 minus 5, sometimes it's given. So for the Q also in the same way, you can calculate it by the replacing this value, substituting this value here. Okay, then we have to construct and we have to replace the V1, V2, means substitute V1, V2 and find out the Jacobian matrix value. So you can see here 9.6, oh yeah, since it is 1, I don't, nothing changed, I just leave it. So J1, it's 9.6, and J4 also is 9.6. You can see J1 and J4. and then J2 and J3 is 2.8 and minus 2.8. Then we know the delta, we know the mismatch value. We know the Jacobian matrix. You know how this one is calculated. No, this one is this value. Then you have to find out the inverse of this matrix. You can use your calculator or AI. And since here I calculate the inverse of that one, and then delta Q2 and delta V2 are the answer of that one. Don't forget here we have to times it by the another V2, since at this point we divide or times it. Right now we should divide it by this value. Okay, and then if you calculate that value using your calculator, you will reach to minus 0.13 as a delta 2 and delta V2 absolute minus 0.09. Then we have to calculate delta 2 for the first iteration and V2 for the first iteration. This is the initial value. Consider for the V2, it was 1 with the angle of 0. So angle is 0 plus the new one, which is minus 0.13. And this one, note, this is not in the form of degree, it's radian. And then you can use it this one or convert it to degrees, up to you. And then the other one also in the same way. So I divided by 1 and 1 plus 0.09 become the new value. So right now we have the V2, which is 0.91 with the angle of, in the form of, I think I calculated by here, yeah. 0.13 radians is minus 7.45. So minus 7.45. No problem. If you mention this unit for me, you want to write it in the radian also, no problem, and okay. Again, we have to calculate the mismatch. So we know the values minus 1.5, minus 0.5. And if you replace the new value of V2 and V1 inside the equations here, these two equations, you will reach the new values, which are minus 0.1597 and minus 0.1178. Okay. Let's calculate this, how this is the new Jacobian matrix. I calculated here for you again. So the delta 2 is given as this value, and the V2 is also given as a 91. So round delta 2 over P2 over delta 2 is 10, 0.91 sine. This is the angle, and the value become 8.33. As you can see, 8.332. Okay. And then for the next one is 0.9781. You can calculate. Is a bit different this one, since we times it by V2. Of course it is. Q2 over delta 2 minus 3.6592 659, and the last value here is 7.568. Then we have to calculate, this is the Jacobian matrix. You have to calculate the inverse of that one, then times it. Then this one must be times by mismatch value and find out the delta, delta, and delta V. And you can see that the new value for delta delta V2 is this value. So the V2 becomes 0.8886 and delta 2 become minus 8.39. So you can continue it for the iteration 3, 4, 5 in the same way until reaching to the final value. How we can find out the final value? So here in the mismatch value, next time when you calculate the mismatch value here, you can see this is the second round, correct? When you compare with the previous round, which is here, so minus 1.5 minus uh, it's become minus 1.5, minus minus become positive 0.1597. Okay, if you consider the iteration, the rate of convergence of this one, you can see it's 1.5 minus, then become small value, then smaller, 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 smaller. Suddenly it reached to a steady state value. Okay, when you have to compare this value with the previous round, so delta p and delta q for this round and the previous round, when it reached to the steady state, which is very close uh, to each other for each round. Okay, next one, this network, we have bus 1 as a slack bus, 1 with the angle of 0. Bus 2 is a PV bus, so the voltage is given, the P also is given, and last one is a PQ bus. So again, I think here is 100 megawatt. The value is given 500, 400. So don't forget this is divide by 100, divide by 100, and both needed minus minus since it's a load. What else? Oh, the value of the lines also given y12. So it's a z inverse for each one is given to you. Don't forget. So easily you can calculate the y bus if you need. So here is 40 plus 20. Here is 40, 20, and here is 20, 20. Okay. The other values I think is very clear. Again, the P and Q are given to you in a form of equation. First, you have to find out the P values you need for each one. Uh, the Y bus is calculated. The P, the Jacobian matrix. Okay, let's jump to the Jacobian matrix. In the Jacobian matrix, you have to calculate P2 over round of P2, sorry, round of P2 over round of delta 2, correct? Which is here, and then P3 and P2 delta 2, P2 delta 3, P2 over P2 over absolute of V3, and again P3 over delta 2, delta 3, and V3 over V3 times round of P3 over round of V3, and the others you can see 1, 2, 3. Okay. So nine unknowns you have to calculate. Round of P2 over delta 2, you can see by here again P2 over delta 2, so both sides we have delta. For this one, cos inverse become minus sine, and since delta 2 here is a negative, here become positive, so 90 minus delta 2 plus delta 1. Here also in the same way cos we have, and the others remain. So if you check here, you can see it is the same. On behalf of 90, it converted to radians, so no need to convert the radians, the last part, again to the degree. Easily you can calculate. For the others also in the same way you can calculate. P2 schedule is 400 over 100, as I mentioned, is 4. This is for the PV bus, and then this one is for the PQ bus. So delta P2 is P schedule, which is 4 minus 0 for the first round. We don't have any value. YP2 is 0. You can go back here. And see, okay, P2 for the bus 1 is 1 with the angle of 0. This is for bus 1. And for bus 2, again, is 1 with the angle of 0, correct? In the first iteration, V2 also is here. V3 also is 1 with the angle of 0. So for V3 is 1 with the angle of 0, correct? So cos 90 minus 0 minus 0, cos 90 is 0. So times this one becomes 0. Again, here is 0 plus 90 is 90, cos 90 is 0. So this value finally is 0. So the calculated one for the first iteration is 0. As you can see, it's mentioned by here. So the others also you can calculate by yourself. This is the I think the Jacobian matrix 63. Yeah. If you replace this value by here for the first iteration, you will reach to this value. So this is the 63, 21, 21. You can see if you calculate this one, no need to calculate this one. If you calculate this one, no need to calculate. It become somehow a symmetrical matrix by times it by V2. If it's a bigger one, it's much more easier. So no need to calculate lots of variables, the same as Y boss. This is the reason we times it by V, absolute of V. So delta 2 is for the iteration 0 is 0.0275, and then the new delta 2 for the first iteration become this value since it was 0, and then delta 3 also minus 0.1078 radians. Don't forget these values are in radians, and V3 is become the variation of V3 is this one. Then the final value for V3 is given by here. Okay. I calculated for the second iteration. You can see round up P2 over delta 2 is a 61.1921. I think it's close. Yeah, it's close. I don't know why is the for the last digits we are a bit different, but we are close to each other in the case of calculation. So round up P2 over delta 3 is a minus 19, 2.8, 19, 2.7 minus 2.8. V3 is 2.6148. For sure, this one it should be different. Yeah, different since we times it by V2. And then again, as I mentioned, this is the same, so no need to calculate. This one also the same. You can see this one and this one the same. Uh, this one is still different with this one, correct? Okay. When we do the times it by V, which is, I think this one, this is 2, 2, this is 2, 3, and this is 3, 2. Yeah, you can see. I mentioned these two value also become the same, 4.6011. And then the inverse of that matrix, you can see by here the inverse of that matrix. I calculated the inverse of matrix. I just want to show you the final values minus 19. This is round up P3 over delta 2 minus 19.208. P3 over delta 3, 37.5, 5628. V3 round P3 over V3 is minus 4.6011. This is 31, if I'm not mistaken. 31, 2.6148, and the other values given by here. Then the final value calculated by me, you can see the Jacobian matrix need to be times by the mismatch, and this is the delta 2, delta 3, and delta V3 over V3. When you add up to the previous value for the iteration 1, which here was 0.0275, this one is minus 10.78, and you can calculate for the others. This is the final value you can reach out to. So you can continue for the iteration 3, iteration 4, 5, 6. It's up to you until reaching to the steady state or minimum variation in mismatch value. Okay, the last question is a fast decouple algorithm. Fast decouple algorithm, as I mentioned in the class, it stopped to calculate such a big equations, round of delta 2 over blah blah blah. Okay, we're just using the Y boss, the B part, which is G, the Y. If you can recall your memory, the Y is G plus JB. So we use only this part, only and only this part. If it's a P Q, if it is no, this is still PQ. Later I show you where is the PV bus. For the PV bus, we only use this, only use the self data. Okay, so we trying to calculate delta 2 and delta 3, correct? So you have to find out the B for the matrices connected to bus 2 and bus 3. So if you're looking at this one, bus 2 and bus 3, where are you, bus 2 and bus 3? So here is 60, 40, 20, 60, and then bus 3, if you look at bus tree, is 40 with 20, 20. Between this one and this one is 20. Of course, the opposite way also in the same value. So let's go back 60, 20, 20, and minus 40. Of course, you know why it is minus, why it's positive. So calculate the inverse of that one. Then don't forget we need find out the mismatch in the same way. This is for the uh, Newton-Raphson normally. And then you have to calculate this one, delta 2 minus here. Here, what is this? This is the mismatch value, which is a power divided by the voltage. So we bring it the voltage in. Here also we bring the voltage for V3. This is V2 and this is V3. So after calculation, you reach to a new delta variation, which is 0.0262, and the other one is given. In the case of the PV bus, you can see B double prime, only minus 40 needed. So delta V3 is minus 1 over 40. This is what is minus 3? Minus 3 is the P, and then this is the voltage value given here. So by its simple iteration without lots of calculation, easily, very easy, you reach out to this value. You can see this value are close. And then next iteration is highlighted by here. Again, first of first, you calculate the mismatch, put it there, V3 and delta 2 and 3. And you can see again, easily you reach to the same or close value. Uh, the fast decouple is not covered for the final exam for sure, so you can review it later for yourself. That's all for the tutorial. If you have any question, you can reaching out to me by email. Thank you very much, guys.